Hello folks, welcome to the Data Science Dossier Unwrapped, the show where we explore the fascinating world of data science. I'm your host, Tom Barber, and in today's episode we'll dive into the difference between a data mesh and a data lake. If you're a data scientist looking to understand these concepts better, you're in the right place, so let's get started. Before we delve into the specifics, let's start with the basics. Both data mesh and data lake are architecture approaches used in organizations to store and manage vast amounts of data. However, they differ in their fundamental principles and how they handle that data. Let's begin with a data lake. Think of a data lake as a vast repository where data from various sources is stored in its raw form. It's like a massive pool where data is collected and stored without any predefined structural schema. This flexibility allows for organizations to store different types of data such as structured, semi-structured and unstructured data all in one place. On the other hand, data mesh takes a different approach. It recognizes that data is not just a centralized resource, but a distributed asset owned by different teams across the organization. In a data mesh, the architecture, data ownership, and responsibility are decentralized, with each team having control over their domain-specific data product. This approach promotes data autonomy and empowers teams to manage their own data pipelines, quality, and governance. Now that we understand the basic concepts of both data mesh and data lake, let's compare them in terms of key factors such as scalability, data governance, and use cases. In terms of scalability, data mesh provides better scalability compared to data lakes. By distributing data ownership and responsibilities, organizations can scale their data systems more effectively, adapting to evolving business requirements and reducing bottlenecks. When it comes to data governance, data lake architectures often face challenges maintaining data quality and consistency. On the other hand, data mesh addresses this by decentralizing data ownership, enabling individual teams to establish their own governance practices within their domains while adhering to common standards. Both data mesh and data lake architectures have their own unique use cases. Data lakes are often suitable for scenarios where data exploration and ad hoc analysis are essential, such as business intelligence and data analytics. On the other hand, data mesh shines when there is a need for cross-functional collaboration and agility, especially in large organizations with multiple teams working on data-driven projects. Now, let's take a look at a real-world example of a successful implementation of a data mesh. We turn our attention to JP Morgan, a leading global financial services firm that I'm sure you've all heard of. They embarked on leveraging data mesh on AWS, demonstrating a real-world instance where the benefits of utilizing a decentralized data architecture became evident. The firm recognized the need for an approach that could scale with their growth and complexity while ensuring data governance, which obviously in the financial services industry is pretty critical. JP Morgan sought to unlock significant business value through the implementation of a data mesh. Their primary goal was to create flexible and scalable system capable of accommodating their expanding global operations. They aim to centralize data ownership, allowing individual teams to maintain and utilize their data more effectively, thereby boosting efficiency and collaboration. In addition, they sought to enhance data governance, ensuring data quality and consistency across the organization. This move was envisaged to drive faster decision-making, enable innovative data-driven solutions, and ultimately provide better services to their clients. Some of the key benefits of JP Morgan's implementation include improved team autonomy with data mesh. Each team was allocated specific data domains, providing them with ownership and autonomy. This decentralization of data ownership serves to enhance productivity and agility within these teams, scalability, and adaptability. The use of data mesh architecture allows JP Morgan to scale their data systems effectively. As the firm continues to grow, their data architecture can adapt and scale with them, thus reducing potential bottlenecks. They had enhanced data governance by empowering individual teams to establish their own governance practices within their domains. The firm was able to maintain data quality and consistency. This decentralized approach to data governance ensured adherence to common standards while allowing for domain-specific needs. They had an improvement in cross-functional collaboration. The data mesh architecture fostered cross-functional collaboration between teams, providing them with the flexibility to work on data-driven projects while ensuring data integrity and ownership. So, JP Morgan employed several AWS cloud services to establish their data mesh architecture, with specific tools playing critical roles. AWS Glue served as the extract, transform, and load service, the ETL layer, managing the processes of data extraction from various sources and transforming it into a suitable format for analysis. It helped the firm to automate time-consuming data preparation tasks and facilitate a smoother data pipeline. EMR, Elastic MapReduce, was used for big data processing. This service allowed the firm to analyze and process vast amounts of data quickly and effectively, facilitating the discovery of valuable insights that drive informed decision-making. They used Apache Airflow, which is an open-source platform that orchestrates complex computational workflows and data processing pipelines, which is something we will get into in a later podcast. It's enabled the firm to schedule and monitor workflows, adding an extra layer of efficiency to their data processing capabilities. They use Redshift, which is Amazon's fully managed data warehousing service. It's offered the firm an efficient way to analyze data using standard SQL. You can leverage existing business intelligence tooling, and this helped JP Morgan glean meaningful insights from their data quickly. And lastly, they used Athena, which is a serverless query service, which sounds a bit like a bit of a misnomer, that was employed to analyze data within Amazon S3. It allowed JP Morgan to use standard SQL to query a whole plethora of data without the need for complex ETL jobs, staging it up in a database. They can just go and query the files in their location, which enhances the speed and efficiency of their data analysis processes. So each of these tools played a pivotal role in enabling the desired state of decentralization, scalability, and enhanced data governance. So in conclusion, JP Morgan's utilization of data mesh architecture on AWS Cloud not only met their immediate needs, but also set them up for future success as the data continues to play an integral role in their day-to-day operations. So summing up, understanding the difference between data mesh and data lake is crucial for data scientists working with large data sets. While both architectures have their merits, it's important to choose the one that aligns with your organization's goals, scalability needs, and data governance requirements. We will be looking at more of a data lake setup in a future podcast. But for today, that wraps up today's episode of the Data Science Dossier Unwrapped. I hope this discussion provided valuable insights into the world of data mesh and data lakes. If you have any questions or if you want to learn more, feel free to reach out to us on the website or through social media channels. Thank you for tuning in and keep exploring that fascinating world of data science.